Okay, so this is going to be for the worksheet Quadratics in Vertex form. So part 1 is asking what we are given. And we are given the A value and the vertex form here, the equation for vertex form. Okay, so number 1, it's wanting us to find the vertex, and it's giving us the A value, and then it wants us to write it into the vertex form equation. So my vertex is going to be my maximum point here, which is going to be -4, 8. So that's what I want to write here, -4, 8. And now I want to plug all my stuff into my vertex form here. So my A value is -1/2, then times x minus, but since my h value is negative, I'm going to say +4, and then squared, and then +8 for my k value. Okay. Number 2, it's given us the vertex, and it's telling us that there's a vertical stretch of 2, so this is going to be my A value here. So again, I would write 2 times x minus 3 squared plus 7, because remember, this is my h and this is my k. All right, number 3. Again, we have to find the vertex, so this time our graph has a minimum point at 3, -4. So that's what we want to write right here. And it's telling us that our A value is 1, so we don't even need to write that 1 out here in the front. So we'll just go ahead and start with our parentheses and say x minus 3 squared, and then -4 for our k value. Okay. Number 4, it's telling us that our vertex is -5 and -2, and that we have a vertical stretch of 2/5, so this is my A. So my equation would be 2/5 times x. Instead of saying minus, we're going to say plus, because my h value is negative, and then squared, and -2. Okay. Now starting back up here at the top. This time we are given an equation. Okay, so on number 1, given our equation, we have to determine what our vertex is. So remember, we have A times x minus h squared plus k. So here I can see that my vertex is going to be 6. But since I don't have a k value out here, I can only assume that it's going to be +0. So it would be comma 0 here. And then my A value is going to be what's out here in the front, so that's 2. Okay, and then to graph this, I know that we would start on the point 6, 0. And then we could look at a picture of the graph here on our calculator. So 2 times x minus 6 squared. And let's see, I know I can plot these points. So 5, I have 5 and 2 and 4 and 8. And then let's see, I have 7, 7, 2, and 8, 8. So my graph would look like this. Okay. All right, so now number 2, they're giving us y equals 5 times x plus 2 squared minus 3. So again, this will be my h, this will be my k for my vertex, h comma k, and this will be my a value. So this time, if you'll remember, usually our equation is supposed to be a times x minus h squared plus k. So the only time this number, or this would be a plus sign, is whenever we plug in a negative value. So that means when I pull this out, I need to make it negative, and then my k value is just -3. And then my a value is going to be 5. Okay, so we know that the -2, -3 is going to be right here. So again, we'll go on to our calculator and we'll input our equation. So 5 times x plus 2 squared minus 3. And let's go to the table. Some really high points. So let's see. There's our vertex. So I know I can do negative. So negative 1, 2, and then negative 3, 2, and then negative, the 17 is not on my thing, so just have to do the best with what I have here. Okay. Now number 3, so our equation is y equals 1 over 4 times x minus 4 squared minus 8. So remember, this is my h, this is my k, this is my a value, and so my vertex is h comma k. So that means my vertex here would be 4 comma negative 8, and then my a value is going to be 1 over 4. So I can go ahead and plot my vertex. That's going to be right here. I'll go back on my calculator to enter this new equation. 1 over 4 times x minus 4 squared minus 8. I'll go to the table. Okay, so I know I can plot the negative 2. So negative 2, 1. And I can do 0. So 0, negative 4. And I can do 2, negative 7. And then 4, negative 8, that's my vertex. Then I would have 6, negative 7. And then 8, negative 4. And then 10, 1, I believe. Yes, I can see that. It's going to look something like this. Oh. There we go. Okay. So now we can turn our paper over. So part 3, we are given a table that we're going to use to pull information out of. So number 1 says, find the vertex from the table below and describe the domain and range. So remember, in order to find our vertex, we can do our little rainbow here to see where we have our symmetrical pairs. So this would just be 1. So my vertex is going to be negative 2, comma negative 3. My domain is going to be all real numbers, and then my range, so I know it's gonna, my y value is going to equal negative 3, and then when I look at the other values, I see that my parabola is going to be going up. I'm going to circle up here. So that means y is going to be equal to negative 3 or anything greater than negative 3. So our range would be y is greater than or equal to negative 3. And then we already found whenever x is 1, our y value is 6. Okay, so now number 2 says, find the vertex from the table below and describe the domain and range. So we're going to find the vertex the same way by doing, oh, I'm doing the wrong side here. So it would be negative 3 to negative 3, negative 6 to negative 6. And then negative 11 would be right here. And since that my x values are counting by 1s, this would be negative 4. So we found whenever x is negative 4, our y value is going to be negative 11. And then we can see that our vertex is going to be negative 1, negative 2. So again, my domain is going to be all real numbers because as my graph continues to grow, eventually it covers all of my x values. And then my range, so I can see that y can be equal to negative 2. And then when I look at the numbers following it, I can see that my parabola is going facing down. So that means y is going to equal negative 2 or anything less than negative 2. So my range would be y is less than or equal to negative 2. Okay, number 3. We want to find the vertex from the table below and describe the domain and range. So again, we're going to do the same thing with our little rainbows here. So I know that behind 2.7 or below 2.7 byte is going to be 2. And when I look over here, I can see that these numbers are counting by halves. So this would be 3. And then below 2 is going to be 0.75 at 3.5. And then -1 down here will be at 4. So I can see whenever x is 4, y is -1. And I can also see that my numbers are decreasing, so we're going down. And that my vertex is 2/3. That's what I want to write here. And then again, my domains will be all real numbers. And then my range, I can see, is going to be equal to 3 or anything below 3 since my parabola is facing down. So y is less than or equal to 3. Okay, number 4. So first we need to find our vertex. And I can see that my vertex is right here at 2, -2. And it's telling me that my a value equals 1. So my equation, I don't need to include the 1, I'm just going to leave it out, would be x minus 2. Remember, this is my h squared, and then minus 2 because this is my k. Okay. All right, so for number 5, let's first find our vertex. So since my y values are repeating here and here, but not with the 0, 7, that means that would be my vertex. And then when I look at my values for my vertex, I can see that they are decreasing, so that means my graph would be facing down. And then I need to find out what my y value would be whenever x is 3. So if I bring down this -11 below -1, I can see that it would go with 3, so it would be -11. Okay, last one, number 6. Okay, so we are given an equation. So from our vertex, we can see this is my h, this is my k. So remember, vertex is h, k. So it would be -4, not -4, +4, -2. And then my a value is going to be 1/3. And so I need to graph this. So I'm going to go, well, first I can always just plot my vertex. So 4, -2, that's going to be right there. So when I go to y equals, I'm just going to change this to 3, and then it's x minus 4 minus 2. So I'll go to the table. And so let's see what I can plot. I can plot the 1, 1. So 1, 1, and what else can I plot? And then -2, 10. And when I go down, I can plot 7, 1, and 10, 10. So that means my graph would look like this. Okay, and this concludes the worksheet for quadratics in vertex form.